Hey everybody, this is Larry, this is me going with Q4 of the weekly contest for 45 count numbers with non-decreasing digits. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. I thought this one was easier than Q3 because I think there's just a lot of components. I mean, I did get a wrong answer anyway, but I did solve it a little bit quicker. I think the hard part about this is just, I don't know if there's a hard part about this, it's just being very careful, and I did not. But I think one thing though is that we've been talking about digit DP for maybe even the last 2 weeks or something like that. And what I mean is just that Leetcode has been giving a lot of us practice on this. So maybe to me it looks or feels easier than it is. But honestly, yeah, I'm just gonna go over it real quick. For this problem, it's just about breaking down the problem. The first thing you need to do is that whenever you see a left-right inclusive thing where you're counting things in between, usually because there's no, you could do it the prefix some way. And what I mean by the prefix some way is just that, let me bring it up real quick. I'm drawing board, right? What I mean by prefix some way is that, let's say you have some function. Let's say you have some function, you're trying to figure out, between some G between L and R, right? And basically you could decompose this into two functions of like 0 from G to L minus 1, or G of 0 to R minus 0 to L minus 1, right? And the reason is that you can kind of just think about it in terms of a line, right? Because basically, pretend that's a straight number line, right? And then you have all these true things, and then you have a prefix sum over all these true things, which gives you like a curve that looks, I don't know, like a step, like a stepwise kind of thing, right? Whatever, right? And then now, so this is to the right, this is to the left, right? So if this is L, this is R, then now you just have to kind of, to get, I'm going really fast, but to get the part that you care about, the L and the R, you just take this prefix sum minus this prefix sum to get this, which is the answer, right? So that part hopefully is straightforward. And then the other thing is that the input is given to you in base 10, which honestly is a little bit weird and confusing because they didn't need to, just try to make you do more work. But in any case, so you convert the base 10 to base 8 for my purposes, or base B rather. For the problem example 1, it'll be base 8, but just base B, right? So here we convert it to base B, right? I'm not going to go over this in detail, but it's just shift and add. If B is 10, I just kind of keep it straight. But yeah, X is a string, so then we just kind of go through it. But for me, just abusing it, Python big int, but otherwise still we just kind of converted one digit at a time, shift and get the last digit one digit at a time, pretty standard stuff, and then reverse and convert it. So yeah, so we do that. We also, like we said, we need L minus 1, so I kind of did it the lazy way. I just converted it to an int, because in Python you could do it to a big int, subtract 1 and then convert it back to a string, convert it to a new base, and then calculate, right? So calculate does most of the work, which is that calculate the number of, non-decreasing numbers from 0 to X, right? And that's basically it. And then most of this function is just this dynamic programming function. We have 3 states for the digit DP. Index is the what index we're on for this number. Last is the last digit that we maybe you could say the last digit, but also like the smallest digit this index can use. And then prefix is whether we're still handling the prefix, right? And what that means is a little bit weird, but we'll walk through a case, right? So I mean, with most digit DP, the way that I think about it is that, okay, let's just say we have some things, and for this problem, we'll just ignore the base and say it is base 10, right? It doesn't matter. And then here we go, okay, we want to find the numbers that's existing here, right? So then the idea here is that, okay, well, what's the first digit? It would be 0. I know it's a leading 0, but but it doesn't matter in the sense that if it's a leading 0, then you could just chop it off later. It just lets you deal with the smaller digits, right? So if it's a 0, and then what happens to the rest? Well, the rest can be anything, right? Because the rest can be anything because it will be still less than 5 million or whatever this number is, right? Same thing for 1s, right? 2s, dot dot dot. I guess the dot 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 just skips over 3 millions, right? But then the 5, you cannot do this, right? Because, well, for example, if this is a 6, then that's not valid. So then now we have to kind of go break it down a little bit. So for 5, and this is where the recursion goes in. For this part, you can kind of imagine it just be we're still on the prefix, and what it means by not suffix is that it's no longer kind of constrained, because here we set the prefix to false because that means that the rest of the digits can be anything with respect to the prefix versus the last digit, right? So you still have to obviously take account the last digit you added, but still, right? Because so these numbers cannot be everything, but everything with respect to the other rows that we have. Right? For example, this cannot be a 2, it has to be at least a 4, right? Anyway, but the 5 is still true, and what now is that, okay, well, now in theory you want to go 0, but you want to try 0, but, well, 0 just by default is not true, and then 1, and then 2, and then 3, and then 4, and then 5, actually, we goes up to 3 because of the prefix, and we're done. Okay, let's actually change the example a little bit, because then this is just trivially nonsensical. But let's just say the first digit is a 2, right? So then now 2, we cannot do that anymore. So then now we try, okay, what's a 2? Well, if it's a 2, then all the other numbers that still holds, and this is how you get the recursion, is still true. So you kind of do it that way. If it's 3, then you can no longer just put everything in between. You have to start with the number 3 in the next one. So then you do recursion that way, right? And that's basically the idea behind this recursion, is that, and we'll go over the code anyway in more detail. It's just that you kind of try the first current digit, one digit at a time, right? Again, if we have prefix, it just means that you have to constrain it to the prefix really carefully. And here, we go up from the last digit because it has to be last digit to be non-decreasing, all the way up to the current digit, not including it. So it's exclusive on the current digit because we know that we have to kind of do a recursion on it. And then we just sum it up to, these are basically, yeah, the next digit can be anything as long as it is bigger than I as it keeps going. And this is a standard DP. Otherwise, we have this constraint, which I did miss for a wrong answer, in case you're wondering, is that while if this digit is still greater than the last digit, which makes the constraint true, then we just kind of keep going, right? Updating the last digit, updating the index, and we're keeping the prefix as true. And that's pretty much it. If we don't have prefix anymore, we go here, which is kind of the thing that we had where we can do quote-unquote anything as long as we are bigger than last, or bigger or equal to last. And that's it. That's all I have for this one. Yeah, this is much more straightforward than Q3 if you ask me. But the idea here is just that, okay, conversion is O of n in the number of digits, roughly speaking, right? Yeah. So O of n time, O of n space. On the calculate index, it's going to be n. The last has at most b number of digits. So O of b. And prefix is just true or false. So this is going to be n times b times 2. So O of n times b. And that's it. That's what I have for this one, and space as well. So that's the number of states. But of course, we do have a for loop in each of these. So it's going to be technically O of n times b times b. Yeah, I'll just write it out. Time and O of n times b state, right? Space, not state. Well, maybe both. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me try to solve this problem live now. Okay. Looks like we're Gucci, so we're happy. Let's do Q3. Now we can maybe take a peek at the cheating. 23 minutes is fine. People I don't recognize at top, as people say, it's probably dubious, but whatever. I count numbers with non-decreasing digits. Alright, 2 integers, return the digits that are not decreasing when, okay, mod. Mod. Okay. 9 degree. If we left to right, it is okay. So here, 9. Oh, increase. Whenever they say non-decreasing and non-increasing, I always get confused. I mean, it's just like, you know, so this one is just sorted, right? So okay. So count the numbers. Okay. I mean, is this supposed to be hard? Is digit DP probably, or just regular DP even, right? Do I have to be distinct? No, I guess it should be. B is only up to 10, base 10. Yeah, that's fine. I don't know why this is hard. That's why I'm like pausing a little bit just to make sure. We shift and add, and we just want to make sure that yeah, digit DP, I suppose, right? All right, let's do one of them first. Okay, go of X, and then for go of X, this is already a string, right? How does digit DP go again? Let's go to calc. So we could name this one go. We have the index, the last digit, okay, so we have the index, the last digit, and then is that it? And like the prefix matching or something. I generally write these down very like, you know, I don't really. Is that it? I guess maybe, I don't know. We'll get to it if not. Index is equal to let's say n is equal to index is equal to n, then we are probably good, so let's just return 1. Otherwise, yeah, otherwise, if this is this the prefix, right? So we go up to the so if not prefix, why use the double negative? Okay, so we pass for now. If it's not prefix, then what? If it's not prefix, then we just keep going. Then we don't even care anymore. Then here we can go from the last digit, right? So here for I in range from the last digit to the base inclusive, we calculate index plus 1, I, and well, it's already false, so it's going to stay false. And then that's it, right? Is that right? Yeah, it should be right. So then now, if it is prefix, then we have, if this is the prefix, we go, okay, for range of I, we start from still the last element. We go all the way up to well, at most b plus 1 for inclusive, but also the x sub index, right? What does 28 mean? in this case. Maybe I think I'm misreading this a little bit actually. This doesn't make sense. The numbers are in, why would they give the string in base 10, but is that right? I mean, yeah, that is definitely right. So here, you have to convert this to the base first, which is really dumb if you ask me, but okay, fine. We could convert. That's not that hard to convert, but that's why I was having confusion. Okay, fine. So that means that this will always be less than b, so that's fine. So then we have what should I call it? We have int of r of index, and then we're Gucci, right? Because we want to be not inclusive of it. So here we have to so we want to be not inclusive of it, so it's going to be false. And then we do want to add the inclusive version, which is going to be still index plus 1. We have yeah, int of index, and then true, right? And then that's it. Yeah, and then it's just about calc right, but then we have to convert right to base. So yeah, so we have to return calc of, we convert L, maybe subtract 1 from L, we'll just put in the function, right? So calc convert R minus this, and then we mod it. Remember that Python mod is fine. So yeah, we have calc, we have to do a convert to base b, right? So this is base 10. That's 100 digits. I think we're fine with 100 digits. So yeah, so we'll just be lazy. If b is equal to 10, then we just return x. Otherwise, yeah, we can, in Python we're okay with this, which is only 100 digits anyway. And then we want to just do yeah, shift, or not shift, but opposite. So while r is greater than 0, answer dot append whatever, string of r mod b, and then r shift by b, answer reverse, return to the join answer, and then we just have to do a subtract by 1 thing, right? I don't think that we need to do this. We can just do int of this minus 1, and then convert it back to a string for other purposes. I think we're good in theory. I saw the none type. I just wanted to see it. 36. Oh, did I forget to return? Convert. Return stuff. Oh, calc didn't return. Yep. Whoops. That is just lazy. So 0. First digit can be anything. So I guess last is 0, and then the prefix is true. Yeah, true is fine. Okay. R of index. Oh no, it's not R, it's X, because it's the thing that we're doing in that context. 4 and 5, okay, not right at all. But that's okay, maybe. Okay, let's take a look at the convert first. Is that right? So that's 7 to 111 is right, and 1 to 1 is probably right. 22, 26 is right, and then it should be 34. Okay, so the conversion is right. That part I was confident about anyway, but this part I suppose we are not. It cannot be 5, just for the obvious reasons that they're not 5 numbers. All right. Did I mess up last? No, it should be okay. Last we could do, oh, we do leading zeros a little bit. I guess last always has to be 1. Because in the way that we construct it. No, but no. Having leading zeros is fine, actually. Because it gives us all the range. Okay, fine, that's fine. Alright, so here we print x. Let's see. Alright, so is that okay? So this 7. So all 7 is thing, and this is all 2, which is definitely not right, right? Hmm. 26. No, that's just every number underneath. So I'm returning 1 for every number. Why? Do I not update last? That is weird. I feel like we're close though. It's okay. Index, last, prefix, total. So that would. Am I off by 1 maybe? Index. That means that this is the prefix. This is false. This is false. I should be fine. Okay, let's see. 0, 0, true is returning 2. 0, 0, true. Is returning 2. 0, 0, 2 is 0, 0, true. So this is true. Alright. It's okay that we do 0. I guess that's fine. The 2 is actually fine, but the 7 is not, because 2 is just 0, 1, and then 1, 0. Oh wait, 1, 0 is wrong. So okay, that's not right either. Let's see. What is going on here? Okay, so it's returning index 1. The last digit is 0, so that's fine. Probably. 1, 1 is 2. So then it returns 2. Oh, returns 2 for 0 and 1. Okay, maybe I buy that. And then 7 is but 7 is definitely wrong though. So okay, let's take a look. This is so annoying to debug. I feel like we're close, but what can it be? Like we didn't write enough code to be this wrong, so okay, 2, 2, force. 2, 2, force would return a 1. Is that fine? Maybe that's fine. No, because there's no 2 in base 2, right? Why is there 2 in base 2? Oh, I have... Huh? Force, so it's here. Base 2? No, 2 is not in base 2, Larry. Come on. Silly Larry. Okay, does this fix things now? 3 and 2. Okay. I hope this is it. Honestly, that is pretty bad of a mistake, but that's fine. We wasted a good amount of time. Ooh, okay. I mean, maybe I could have tested it a little bit more, but I think that's fine. I was happy with the idea, and that was pretty bad. I mean, maybe we need to kind of constrain this thing. No, I don't think so, because these are already converted here. Okay, so let's kind of take a look. Have a quick wrong answer. That's good, maybe, and this is easy to debug. 1 and 5. The answer is 2. Or what is 2 again? Oh, base 2. So you have 1 and 101. I think this is wrong, because I just don't have the if statement of if int x of index is less than b, or this is less than or greater than or equal to last. I think that's what I needed. Okay. Yep. Yep. Silly. Okay. YOLO submit again. Okay. So I mean, okay. I did miss this case because I was kind of, I don't know, I got lost a little bit, but I was relatively confident about it, honestly. Because I don't know how else I would, like, other than minor typo E, silly E things, I didn't know how to really solve it otherwise. Or like there's just not many places to make mistake on. So I don't know. I feel like this was pretty okay. I mean, I feel like, but like this is as happy as I am with a content. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this forum, this contest, everything between. Yeah, I'll talk to you later. Stay good, stay healthy to good mental health, and yeah, have a great week and whatever. And I'll see you later. Bye bye.